I want to talk about security for Chainlink node operator from the node operator perspective. So a couple of assumptions I make here, or factors I weigh in here, might not be important in the big picture, but are important for the single button, Oracle node in this case. So let me start. We were introduced as one of the largest staking providers. We started out as just the three guys. It's me, Leo, and Richard. You and I have a very strong background in IT security and cybersecurity. So we spend a lot of our time just breaking other people's code. And so do we try to break our system every time we come up with a new one. And we iterate that way. And so have we been iterating a lot on our Chainlink setup very recently. And I just want to dig a bit into a couple of attack vectors that we identified for Chainlink node operators and how we try to approach and mitigate them. So, in general, let's take a look. This is kind of a very rough overview of how a Chainlink node operation looks like. We have a centralized database per node operator which stores some state, stores the jobs that we have. For example, if we have an ETHUSD job or BTC ETH job, these have to be registered on our node so we know which API endpoint to call when we get a request on chain. And this database is then accessed by a couple of Chainlink nodes. So we run a couple of those just for high availability. If one of the nodes dies, another one kicks in. The database is used for synchronization. So we also try to keep that one highly available. And we're using a couple of different node providers to feed in the data. And looking at the trust model here, it's very apparent that all of these components are very critical. We can't just randomly trust the ETH node, but we have to. So the ETH node is something that's very critical in this part because the ETH node just sends us the headers of the new blocks. It sends us events that happen on smart contracts. For example, that one of the jobs has been called and we received the request. So something that could happen on that front is just denial of service from an API provider. So we, for example, we are primarily relying on Alchemy API and have fallbacks to Infura, and a couple of other node providers run their own nodes. And it's very important to keep this aspect of the node in your threat model because compromises on this side can compromise the whole node's security. At the same time, essentially, the Oracle is not just the node, but the most important factor, and that essentially applies to everything we do as validator operators, is about the key. It's always the key because the key that signs the transactions is what identifies us on chain. So in this case, the key is stored in the database. And it's stored in an encrypted form, but obviously the nodes have to decrypt the key in order to send out transactions. And this is why it's very important that we come up with proper strategies for managing those keys. So we have another attack vector there. And the cool thing is that this key is rotatable. So there's no key that's stored in the database that's fulfilling our requests. Essentially, like we get a request on chain, we generate a transaction, sign it using that key, and send it back. But the cool thing is we have another key that we can hold in cold storage, for example, which is the Oracle owner key. And that one essentially allows us to change the ownership of the Oracle smart contract, change which fulfillment keys can be used. So which keys we allow to respond to our Oracle requests. So looking at that, we have a couple of risks that are like very high level. We have account key exfiltration, which is someone stealing the key we're using to control the Oracle smart contract. Compromise of that means they can steal our rewards. So from business continuity perspective, that's probably not the best thing to happen. The fulfillment keys could be exfiltrated, which is obviously, in the best case, it's much easier because these lie on the nodes. They have to store this in memory in order to be able to sign transaction at a speed which is heard. Like we, for example, are responding usually within 2 blocks. That's not doable with offline signing or anything alike. Then we have denial of service. Some of our API providers could just not serve us anymore, and we would go down. That's no problem in the whole ecosystem because obviously Chainlink has aggregator contracts. They source responses from different Oracle providers, different operators, and get an image from that and sum this up. But for us in particular, that we want rewards and that we want to provide a good service to the people that will potentially stake to us in the future, it's very important that we do not go down. And at the same time, we are reliant on the data providers we use to source the data that we are putting on chain, then, for example, price data of ETHUSD. So that's another point where someone could attack us in different ways. So looking at the account key, this is, I already mentioned it, it should be held in a cold storage. So usual ledger or whichever procedure you want to use. The thing is, there can only be one owner on the normal smart contract, on the normal Oracle smart contract. And we can use that to swap out the keys that allow to fulfill our requests, and you can claim the reward. So this is the very important key. Luckily, we rarely have to use it. We have to use it to claim the rewards and cash out or move the link tokens to another address, for example, or in order to rotate our keys, which is generally best practice to do that every now and then if you want to have stuff like proper processes. But one cool thing that we've been thinking about recently is we could also create a multi-sig contract and make that the owner of the Oracle. So a single key can't access the Oracle smart contract alone anymore. And that's actually possible. For example, we are not, like, our ledgers don't actually own the Oracle smart contract for Certus.One, but we have another smart contract that's already in the middle that we've co-developed with DexBlue, which helps us automatically restock our ETH node with some ETH which we can use to serve requests. So this is about the account key. Then we come to the more critical part of the fulfillment key that's essentially a hotkey. It's a hot wallet that we store on each of those nodes, and single host compromise there is extremely critical because people could drain our ETH, which means we can't respond anymore and we probably lost quite some money depending on how much we keep in stock. And they could use it to sign just malicious responses, which cost us and our delegators in the future a lot of money. And that's obviously something we want to prevent, and this is where we at Certus.One have started to implement some processes and implement new software to mitigate these issues. And one thing we've actually started to implement is what we call SignOS. SignOS is kind of like a software key manager, and we built a very secure own operating system that's using the state-of-the-art trusted platform modules or AMD's SEV technology to establish a root of trust in the machine, which means we have similar guarantees to something like a ledger, but we can actually run software on top of it. Meaning, we can do some very interesting things. We can remove the keys from the database, we can remove the keys from the single Oracle nodes, and we can use a centralized key management solution, which is essentially shielded off. It's more like a ledger than it is a normal server. There's no way to SSH in, access a console, extract keys, and it's totally separate from our node infrastructure, which touches the internet. So we can also have them in a VPN and have the key cluster not connected to the internet. And the cool thing we do in the SignOS cluster is we can apply logic to verify the transactions that are being signed. So for example, if the node asks SignOS to sign a transaction which would be a response to a request on-chain, SignOS would obviously say, hey, okay, that's valid, that's my job, and sign the transaction, and we can then broadcast it through the chain. But what it would also do is, if suddenly a node came and said, like, please send 5 or 50 ETH to another address, that's not what our Oracle node should usually do. And SignOS would detect this anomaly or wouldn't allow transfers at all and not sign this transaction. At the same time, we can do plausibility checks on the values. For example, is the ETHUSD price really just $2? We can do all of these checks within this highly secure operating system, the secure enclave, and we can take the trust barrier and push it further to the keys and away from these nodes that touch the internet in the future when the new Chainlink API is being implemented. So obviously, the SignOS cluster would say no to this transaction, prevent business continuity problems on our side, because we would run out of money if someone just stole all the ETH, and it would keep our node up. Which brings us to node being up. we are relying on third-party API providers, for example. Obviously, we are paying API providers, we have service-level agreements with them, and we can expect a certain service level. At the same time, they can trick us. Up until 2 weeks ago, we were still using a very primitive version of monitoring for Chainlink, which essentially just checked our node and our logs and was listening for failures of jobs. But what could happen is that actually these APIs just start sending us valid transactions where nodes would think like, okay, this is okay, or just send us orphaned blocks. The node wouldn't notice. We probably wouldn't have noticed. So we need to be a bit more concise about what exactly we need to monitor. And this is where we started to develop a new monitoring tool, which actually looks at the Ethereum chain and looks at the aggregator contracts that Chainlink has put out and actually verifies that we've given, one, a response at all, second, a response in time, and third, a response that makes sense, so not a 10% deviation between two calls that were just 5 minutes away from each other. And we've actually open sourced that tool. What it does, it doesn't rely on the single node, but it actually listens on-chain and can consume multiple API providers. And it's a Prometheus exporter, so you can use usual Prometheus, Grafana to create dashboards, look at the performance of your node, because that's a cool thing. Just having heard about the core rating system, we can now also track a histogram of like how fast were we at responding to contract calls. Maybe some are slower, some aren't. And this is extremely important, not just from a performance perspective and reliability perspective, but also from a security perspective, because we only receive rewards, and in the future, when there's stake, we will only be up on the chain if we actually have valid responses on the chain. So we need to monitor exactly that one. And this has been a very good iteration for us recently to just go to the next step and start implementing better monitoring that actually tracks the right things. That's one of the most important things for node operators, looking at the right metrics and putting all of them together to form a very secure node in the end. And so we have the key management part, we have the uptime part, and obviously, I don't want to dig into that, but having good processes in place where multi-sig contract could be a part of. To, if the team's growing, if the Chainlink ecosystem takes off even further, a single person can't compromise the oracle and potentially cause millions of dollars in damage, and obviously prevent Joan from being woken up in the middle of the night, which happens if we go down. Thank you.